class, this is Mrs. Lyons going to try this again. My last video kind of got chopped off a little bit prematurely, so I'm just going to kind of do a couple of those last problems again where we were starting with some of the math and at the bottom of page 6 on the review guide. So I'm just going to do those. You'll see them twice possibly, but I want to make sure that we've got them in there. Or maybe I cut them off on the last one. I'm not even sure. Anyway, we are going to start with number 30 on page 6. Okay, and this is getting us into some of our conversions. Okay, so the first one is a mole conversion, and pretty basic, except it starts, instead of just starting straight out and going from grams to moles or moles to grams, it's asking us to go from milligrams to grams to moles. Okay, so here we go, number 30. So it says we have 32.8 milligrams of calcium chloride. Okay, and we want to know how many moles that is. Put that over 1. The first thing that we want to do is convert milligrams to grams. Okay, so we need to know that, oops, let's see if I can get this to work. There we go. We should know that there are 1,000 milligrams per 1 gram. Okay, and then the next thing that we're going to do is we are going to use the molar mass of calcium chloride, and we know that the molar mass is equal to 1 mole of calcium chloride. All right, so we have to find the molar mass. Okay, so we've got 1 calcium, 2 chlorines, so that is going to be, calcium is 40.08. and chlorine is 35.45, so if I have 2 of those, it's 70.90. So my molar mass of calcium chloride is 110.98. Okay, so let's do the math. All right, so 32.8 divided by 1,000. And then divided by 110.98. That gives me 0.000. I can have 3 sig figs, so 296 moles of calcium chloride. If you want, you can write this in scientific notation, so it would be 1, 2, 3. It would be 2.96 times 10 to the negative 4th. Moles of calcium chloride. Okay. All right. Moving on to number 31. I hope I had that up there so you could see it. So moving on to number 31. There we go. And this one we got to think about a minute, because this says how many carbon atoms are there in 3.8 moles of carbon dioxide. Okay, so we are going to start with 3.8 moles. Let's see if I can write it in here. No, I'm going to write it on the paper. So let's see, we've got to start with 3.8 moles. So number 31, 3.8 moles. Got to double check. 3.8 moles of carbon dioxide. And we want to know how many carbon atoms. So the first thing that we have to do is figure out how many carbon dioxide molecules there are. Okay, and this is where we will use Avogadro's number. Okay, so we know that 1 mole of anything, so 1 mole of CO2, is going to have Avogadro's number, so 6.02 times 10 to the 23rd molecules of CO2. Okay, So that's relatively straightforward. That tells us how many molecules of CO2. The problem is asking us, though, how many carbon atoms. So what you have to do is you have to look at how many carbon atoms are there in one molecule. Okay, so we're going to have one molecule of CO2, and that is going to contain just one atom of carbon. Okay, if I were asking for how many oxygen atoms, it would be for every molecule of CO2 we have two oxygen atoms. So let's do that calculation. So 3.8 times, I turn my calculator sideways, times 6.02 times 10 to the 23rd times 1, which we really don't need to do times 1, but just for the heck of it. And we can only have 2 sig figs. So my answer is going to be 2.3 times 10 to the 24th. And I want to make a point. When you are doing these calculations, make sure that you always look over here on your calculator to see if there's an exponent. Okay? Because if you were just to put 2.3, you would be way off. Okay, so the answer here is going to be 2.3 times 10 to the 24th carbon atoms. Okay. All right. Uh-oh, I got all blurry. Oh, there we go. Okay. Today is just not my day. All right, let's see what we have next. So the next question, okay, so the next questions are to write a net ionic equation, okay, for the following reactions. So to do that, we are going to need a periodic table. Let's hope I have a periodic table at home. It has my solubility rules on it. There we go. All right. Sweet, that is my chair. How is it possible that I always end up at home without a periodic table? All right, so we're going to jump back and forth. I'm going to pull up a periodic table on my other computer, and we'll kind of bop back and forth between the two between the two screens. All right, so we're going to go here. I'm starting with that. All right. I'm going to go grab my periodic table. While I'm doing that, I talked to some of you today and told you my crazy story about what happened to me this morning. So this morning I decided I was going to get up early. I was going to get to school super early, and I was going to make videos for all the pages of our review guide. And that was my intention. So I got up at about 3:30 this morning. I was at school by about 5:20. And when I got to school, the most awful thing happened. I started to use my program for, it's Screencastify is the program that I use to make videos. And when I opened up to make my first video, I got an error message that said, you have made as many videos as you are allowed to. You cannot make any more videos. So I got on the phone. Let's see, I need a different. I emailed. So I emailed the people at the high school. I emailed the people at district office. I emailed our instructional coaches. I emailed the people at Screencastify. And finally, by seventh period, about the end of seventh period, no, the beginning of seventh period, I actually was able to go into my account and make new videos. So needless to say, I did not get videos made bright and early this morning, so I'm doing them this afternoon. Okay, so now that I found what we need, solubility rules, okay? When you write a net ionic equation, remember what you're doing is you're looking at if two of the ions combine to form a precipitate, something that's insoluble, okay? If everything in your double replacement reaction is aqueous, we would say that there's no reaction takes place. Okay, and remember our solubility rules. All metal, group 1 metal cations are always soluble. The halogens are soluble except for these few exceptions. Ammonium nitrate, chlorate, perchlorate, acetates are always soluble. And then we've got the list down here of insoluble compounds. Okay, so let's look and see what that means for us, okay, as we are looking at how to write a net ionic equation. So this first reaction says that we have sodium chloride and silver nitrate. So let me get my notebook up here. So sodium chloride, okay, so we have sodium and we have chlorine. Remember, in order to write the formulas, we have to look at the charges. So sodium forms +1 ions, chlorine -1, so that's just sodium chloride. And then the other compound was silver and then nitrate, NO3. Turns out silver's +1, nitrate's -1. So this is really handy. It's already, we don't need any subscripts, okay? Now, in a double replacement reaction, what's going to happen is the sodium and the silver are going to switch places, okay? So we're going to end up with NaNO3, okay, because we know the charges. And then we're going to end up with AgCl, silver chloride, okay? So now that we've got this, we have to look and we have to check our solubility rules for nitrates, for silver, for chlorine. Okay, so let's hop back to the solubility rules real quick. And if you look, group 1 metals are always soluble. So that means sodium is in group 1. It's going to be aqueous, AQ. Okay, and then remember chlorides are soluble always except, notice that silver. When it's silver chloride, that is going to be a solid. Okay, so hopping back over here. So if I write just the general equation, I have aqueous sodium chloride and aqueous silver nitrate reacts to produce sodium nitrate that is soluble and silver chloride. So remember, in writing a net ionic equation, what you do is you break everything down that's aqueous into the ions. So we would have sodium +1 plus chlorine -1 plus silver, silver is always +1, plus nitrate -1, okay? And I didn't leave very much room to write. I'm going to put it down here. So then we are going to, our products are going to be, I'll try to squeeze it in, sodium +1 plus nitrate -1, both aqueous, and then plus silver chloride. Since that's a precipitate and it's insoluble, on the product side, it sticks together. Okay, so now if you remember net ionic equations, what we've got to do is we have to look at both sides of the reaction, and anything that appears exactly the same, we cross off. So sodium, we can cross that off. And then we can also cross off NO3, NO3. Okay, so if we rewrite this equation, it turns out that we have chlorine aqueous plus silver aqueous combines to produce AgCl solid. Okay, those ions that we crossed out, we call spectator ions. And they're spectator ions because they don't participate in the reaction. Okay, so that term fits nicely. All right, so there's two more examples of these. Let's see, lithium phosphate and magnesium chloride. Okay, so let's do this. So lithium phosphate, let's just write these down. Lithium's +1, phosphate is PO4 -3. What did I say? Lithium phosphate and magnesium chloride. Magnesium is +2, chlorine is -1. Okay, so that just kind of tells us where we're starting. Okay, so lithium phosphate would be Li3PO4 aqueous plus MgCl2 also aqueous. Okay, what's going to happen, that lithium and that magnesium are going to switch places, so we would end up with magnesium. Okay, magnesium's +2, phosphate's -3, so Mg3PO4. Okay, we got to figure out if that's a soluble or insoluble, and then we would end up with lithium chloride. Okay, so now we have to hop over to our solubility rules. Now, this is one that some of you, when we were doing this, you remembered, because you can remember that always, if you have a metal in group 1, that is always going to be soluble. So lithium chloride is soluble. Okay, and then let's pop over here and check on magnesium and phosphate. So let's see. So phosphates are always insoluble unless, and notice it says unless they have a group 1 metal, which we don't. So that means that our phosphate, our magnesium phosphate, is going to be a solid. All right, so that is what our precipitate is. Okay, so now we have to break this down into the ions. Okay, so we are going to have, and this one's not quite as straightforward because we do have some subscripts to contend with. Okay, so we have 3 lithium ions plus 1 phosphate ion, and then we have 1 magnesium +2 ion plus 2 chlorine ions. Okay, so when you write this out, the subscripts become coefficients, because if we were to write Li3, that's a compound that doesn't exist. That would mean we had 3 lithiums connected to each other. That's not what we have. We have 3 lithium ions that are separate from each other. All right, and then we're going to write magnesium phosphate as a solid. Oh, I screwed up almost. Yeah, that should be Mg3PO4 too. I hope you were screaming at your computer saying, Mrs. Lyons, you made a mistake. All right, but I caught it, thank goodness. So this is our solid. So this is just going to stay Mg3PO4 2 solid. And then you have, you know what we didn't do? We can do this. We end up with lithium +1 aqueous plus chloride -1 aqueous. Now, before we go any further, and we can do it at this step. It might actually be easier at this step to balance, but we need to balance our equation, okay? So for example, I have 3 lithium ions here, so I need to have 3 lithium ions over there. I have 1 phosphate here. Over here I have 2 phosphates, so I'm going to put a 2 there. Magnesium, I've got 1 here, 3 here. And then I have 2 chlorine here. I need 2 chlorine over there. So even your net ionic has to be balanced. But just like I did, you can balance it after you've already broken the ions down into their individual components. All right, so the next step is to cross off anything that appears on both sides. So lithium, 3 lithium. Over here we have 3 lithium over here, so we're going to cross that off. Phosphate is part of the solid. Magnesium is part of the precipitate solid. Then we've got 2 chlorides and 2 chlorides. So finally, our net ionic equation is going to be 2 phosphate ions combined with 3 magnesium ions to produce Mg3 PO4 2 solid. All right, so that would be our net ionic equation. Lithium and chlorine are our spectator ions for that one. Okay, let's do one more of these. Hopefully you're getting the hang of it by now. Let's see, aluminum bromide and sodium carbonate. Let's see if I can remember this long enough to write it down. Aluminum bromide and sodium carbonate. So aluminum bromide and sodium carbonate. Now notice I just wrote down the ions. I haven't done anything in terms of charges. All right, so aluminum is a +3 ion, bromine is a -1. So that's going to be AlBr3 aqueous, plus sodium is +1, carbonate is -2. So we're going to have Na2CO3 aqueous. All right. So aluminum and sodium are going to swap places, so we will end up with aluminum carbonate plus sodium bromide. Again, we've got to look at charges. So aluminum is +3, carbonate is -2. So that gives us Al2CO3, 3. And then sodium is +1, bromine is -1. Okay. Guess what? I'm at home and there go my puppies going crazy. That's why I went to school at 5:30 this morning, was to keep the puppies from disturbing my video. Okay, so try to ignore them, and so will I. Let's see. So we need to look at our solubility rules. Here we go. Sodium, we know. Hopefully, even just after doing 3 of these, you remember anything that's in group 1 is always soluble in water, which probably means that that aluminum carbonate is not soluble in water, but let's check it out. So carbonates, sure enough, carbonates are always insoluble, which means that this is going to be our solid. Okay, now let's balance this one first, just because we didn't do it last time. So let's see, I have 2 aluminum in my product, so I need 2 aluminum in my reactants. That gives me 6 bromine. Over here I've only got 1, so this is going to be a coefficient of 6. I now have 6 sodium. Here I only have 2 sodium, so 2 times 3, that gives me 6 sodium. And that gives me 3 carbonate, which I had 3 carbonate, so I should be balanced. This is just a 1. All right, one more time. Let's do this net ionic business. So we end up with, and this one's a little harder. Everyone has got a little bit of different slant to it, a different kind of we have to tweak it just a little bit differently. So we have 2 aluminum ions, and we have how many bromine ions? Okay, you've got to consider the subscript of the 3 times 2, so we have 6 bromide ions, okay? And then we also have 6 sodium ions. and we have 3 carbonate ions. And those react to give us solid aluminum carbonate plus 6 sodium ions and 6 bromide ions. All right. Whew. So let's see, what do we have on both sides? We've got 6 bromide over here, 6 bromide over there. I have 6 sodium here, 6 sodium there. So I have left, those are my spectators, I have aluminum plus carbonate produces aluminum carbonate. Oh, you guys, and I did it again. There should be a 3. Okay. I'm tired, I'm making mistakes. Hopefully I'll catch them all though. Okay, so let's write the net ionic. The net ionic is going to be 2 aluminum ions plus 3 carbonate ions produces Al2CO3 solid. And notice I caught my mistake, so we actually balanced there. Whew. All right, let's see. Is that all for that page? That is all for that page. So we are going to stop right there, and I will make another video in a minute to move on to page 7, but I want to kind of chunk this. So I'm sorry that this was delayed a bit. I hope that it helps as you're studying this weekend. Have a great weekend, and I will probably see many of you on Monday.